Today we're going to look at ratios to solve problems. A ratio is a comparison between two numbers. Ratios happen in a variety of contexts, including a straight comparison, like 4 parts of oil to 1 part of vinegar, or a rate, such as 60 miles in an hour, or a scale, like 1 inch equaling 100 miles. When you solve problems involving ratios, usually you end up writing a proportion. So look at this example. If there are 95 grams of fat and 16 ounces of hamburger, how many grams of fat are in 3 ounces of hamburger? I know that the proportion of fat in the hamburger isn't going to change regardless of the weight. The ratio stays the same. So this is a problem that I can set up using a proportion. First I look at my ratio, and my ratio is going to be grams of fat to ounces of hamburger. So now I write my proportion using the information from the problem. 95 grams of fat, 16 ounces of hamburger, that was my first set of given. And now I don't know how many grams of fat, but I know that I want 3 ounces of hamburger. So my proportion that I'm going to solve is this one. Now just a quick review on solving proportions. Remember that you cross multiply in order to get an equation and then solve that equation. So we find that there are 17.8125 grams of fat in 3 ounces of hamburger. Now remember, when we set this up, we made a ratio of grams of fat to ounces of hamburger. So when I set my proportion up, it needs to stay in that same ratio, grams of fat to ounces of hamburger. So I'm going to keep the grams of fat in the numerator, and I'm going to keep the ounces of hamburger in the denominator. I could reverse that. I could have done ounces of hamburger and grams of fat, but then that means that I want my ounces in my numerator and I want my grams in my denominator. And that's okay. Just make sure that you're consistent about those ratios. When I cross multiply, I get the same equations. It's just the second one is reversed. Be careful, because sometimes you set up the wrong ratios. Here I started with ounces to grams, but my second equation became grams and ounces. When you look at the results when you cross multiply, you'll see that these two equations are not the same at all. So it's really important to make sure that you keep those ratios the same. Here's another example. Peanuts sell for 75 cents a pound. Rosie has 50 cents. How many pounds of peanuts can she buy? I'm going to set this one up as dollars to pounds. Now remember, we could set it up the other way, so it's not wrong if you were thinking pounds to dollars. Now I'm going to write my proportion. I'm going to put the 75 cents for 1 pound that I know, and the 50 cents that Rosie has, but I don't know how much she can buy. So that's the proportion I'm going to solve. And by doing so, I see that Rosie can buy 67 hundredths, that's 2/3 of a pound of peanuts. Okay, now here's one last problem, and this one you get to solve. It says a recipe uses 3 cups of grated cheese to make 10 servings. How much cheese is needed to make 6 servings? I'm going to wait a little bit, let you set up the ratio and the proportion. Start solving it. If you don't get it solved, that will be fine. We'll work on that in a minute. Okay, I set it up with cups to servings, which means I used my given to get this proportion. When I solved that proportion by cross multiplying, I got this equation, and that solves to 1.8. So I know that I need 1 8/10 cups of cheese for my 6 servings. That makes pretty good sense. 6 is a little more than half of 10, and 1.8 is a little more than half of 3 cups. Okay, that's it for this video. Now you've got some problems involving ratios and proportions. Remember, if you have any problems, check with a math teacher.